Hello guys, my name is Mr. Garcia and I'm back with another video, mid-segment of a triangle. I'll talk about what you need to get in a bit, but for right now, there's a little subtitle for today's lesson. I'm in the middle of a segment here with my triangular friend. Man, that's definitely a good old subtitle. Maybe your triangular friend is Phineas a verb? I don't know. Objectives today. I want you to be able to construct the mid-segment of a triangle using patty paper and a straight edge, and then find the missing length of a triangle by using the triangle mid-segment theorem. So, for this lesson, you need the following materials: a piece of patty paper, you need a pen, pencil, or marker, just some writing utensils. I'll be using some flare pens, and then some straight edge. So that straight edge can be a ruler that I gave you, or really anything else in order to make a straight line. Doesn't really matter. So we're going to be doing constructions a lot this semester. In fact, those big three things that we're going to cover will be by construction. Oop, my bad. So what is construction? That is the more technical definition. It's the drawing of geometric items, such as lines and circles, using only compasses and straight edge or ruler. And biggest thing about that is you're not allowed to measure angles with a protractor or measure lengths with a ruler. So there's this guy named Euclid. He has this book called The Elements, and he was like the father of geometry per se. This is a thing of how we can prove. We can prove that these certain theorems exist by construction. Now, we won't go into the proof this semester, but we will be constructing it. And also, it kind of helps you visualize it as well, because you're literally manipulating it with your hands. We'll be constructing it using this piece of patty paper, but I think I am too boring of a person. I need to bring in a special guest. I brought in this guy from the depths of the other side of the world. Like he was meditating in the temple, and I had to go through so much process just to get him. I'm surprised I got him, honestly. So let's hear from him. Let me throw it to him real quick.
Oh, I have been called. I have been summoned to show you the way of the patty paper. Now, it is my understanding that you have no prior knowledge of the secrets of the patty paper. I'm going to show you a secret knowledge that's been passed down from generations to generations of constructing the mid segment of a triangle. Now, let us continue. So if you do not have these materials present, you need to acquire them as we speak. So first, we will begin with the patty paper. This has been harvested from generations and generations. Families and families have constructed these. So first, I'm going to take the patty paper and we'll draw the sharpest, the strongest shape known to man that has been since of old, a triangle. Now the important thing about this triangle is it doesn't matter what kind of triangle it is. For the purpose of this demonstration, to show you the way, I will construct an acute triangle, as we can see in this patty paper. Acute triangle. Why is it acute? All of the angles are less than 90 degrees. Now, the mid segment. In this case, the first thing I need to do is find the midpoint. Since this is we can find the midpoint very easily. Now, do not show this to anyone else. This has been passed down for generations. If you show this to other people, I will have to hunt you down and to find the key contain the secret. Take each side of your triangle and fold it on top of each other and make a little crease right there. As you can see, we have made a crease in this segment. That point right there, that point is our midpoint. Make a little mark right there. We're going to rinse and repeat with all of the other sides of this triangle. So on this longer side that I made, I'm going to do the same thing. Fold your triangle on top of each other such that the sides even out and make a mark at the midpoint. Again, the midpoint. Now on this last side, we'll be doing the same thing. That is the benefit of the paper ball because you can see each side line up on top of each other. Now, after we made that last point, I am now going to take my straight edge. I will not be using my nunchucks, although I am skillfully mastered in them. Now, take your straight edge, my ruler in this case. I am going to make a mark across all of these points. So from midpoint to midpoint, I'm going to draw a line. So on this first midpoint, just draw a line connecting them. As you can see, I drew a line. Now I will repeat that same process for all the other midpoints as well. As you can see, I have now drawn 3 lines connecting the midpoints. As my great ancient ancestor Link and Zelda from The Legend of Zelda, this represents a Triforce. Now, the purpose of this is to determine the mid segment. I'm going to take a different color for illustration purposes. But now, I'm going to go ahead and label some of these. I will label them, doesn't really matter, but I will say A, B, and C. I will start with A and keep going. So I just label them A through F. A, B, C, D, E, F. Here is the cool thing about the definition of a mid segment, or of a midpoint. Since F is a midpoint between A through E, that means that these two segments are the same length. So what I can do is I can put a mark between those two to show that they are indeed the same length. Same thing on the other side. D is a mid-segment between C and E. Therefore, these two sides are the same, and you are correct. Young Padawan, you are learning. This side right here is also the same. Now, this brings us to the term mid-segment. In this case, we have several different mid-segments. It must satisfy a couple things. One, it must be parallel to the triangle's base. So if I have my triangle oriented this way, my base would be AC. That would be my base. The mid-segment is the line that is parallel to the triangle's base. So FD would be my mid-segment. So here is the notation for that. Notice I'm going to write a couple things here. Yes. I have been waiting for this. The legendary pointed finger. Tales of old have been told of this. Thank you, young master. I will take now and show you. FD. Notice the line above it. That means line segment. Parallel to AC. This says line segment FD is parallel to line segment AC. This is important for one reason, and one reason alone. This tells us that FD is the mid-segment around a triangle AEC. So, FD is actually 1/2 of the base AC. Again, FD is one half of the base of AC. We will see now in a bit with our young apprentice, Mr. Garcia, on how that looks like more. This is called a construction. We use a straight edge alone. We did not try to guess. We use our petty paper. I thank you for this time. I have to go. I have to vanish. Again, this is a secret that must be kept for generations to come. Thank you.
Wow. What a definitely a special guest. I personally was honored to have um, master geometrists in our building, in our site. Geometrist Euclid was definitely a great influence in my life, and I'm surprised we had managed to get him. He actually had to leave. He had went to go back to meditate some more and to eat grasshoppers and crickets. So where you are in your household, if you can please with me as well, just bow. So put a fist against a hand like you do in Avatar The Last Airbender when the Fire Nation bows. Fist, hand, and bow. Simple as that. So as he was speaking about, we are and oh, he left his does he? I guess he doesn't need it. He left his patty paper here with all the stuff, so we'll be referencing that. So constructed the mid segment of a triangle. Definition of mid segment. So what that is the triangle mid segment theorem. A mid-segment is parallel to the triangle's base and one half its length. So that mid-segment is one half times the triangle's base. And so here I'm going to try to do this. It won't be perfect, but this I'm going to recreate what you did on your patty paper. So it won't be the best, I know, um, and honestly, it's not going to be accurate whatsoever. So again, this is just a really rough example, just to make sure we understand what the mid segment is. So here, I'm just going to pretend that I already found the midpoint right there, and oop, my bad, and right there. Obviously, we know that the midpoint is going to be in the middle. It's not perfect. I know it is, but we'll get there, right? So here, the next part we did was it connected our midpoints, correct? Perfect. So I connected my midpoints. Now, here, let's go ahead and do some labeling. Since we're doing an example, it doesn't really matter too much what our labeling is, but I'll keep consistent with what you did on your patty paper. So with this here, there are a couple things that we saw. We'll do blue. Since point F, D, and B, since those are midpoints, that means that AB and BC are the same length. Same thing for CD and DE. So notice, if you don't know this notation already, it's the tick marks. These two tick marks on the bottom here, so let me get my laser pointer. These two tick marks, that means that these two sides are the same length. Same thing for these two tick marks. These two sides are the same length. And as you guys caught on, that means that this last side, 1, 2, 3, 1, 2, 3, that EF and FA are the same length. So that's good. So this brings us to a different notation. We'll do black. We have a mid segment here. Now, and the way this triangle is orientated, my base is the AC. And that means FD is my mid segment. So FD is parallel to AC. Again, those two double bars, that is parallel. And the line above the letters, it means line segment. That's important because for this triangle, what that says is that FD is equal to 1/2 times the base of my triangle. So this is important because if I know either my mid segment or my base, I can solve for the different sides of my triangle. Now we'll do some examples in a bit of how that practically works out. But one thing to note, yes, it is that FD is a mid segment, but it's not the only one. This is going to be kind of hard to see, so try to like picture in your head, and if it helps, use the patty paper. So we had this right here, right? FD and AC. Those two were our corresponding stuff. Well, what if I did this? Okay, what does that mean? What does that look like? Well, it's kind of hard to see. Again, look at your paper, but it looks like AE is now the base, which will make BD a mid-segment as well. And then also here, what if we kept turning? CE is our base with BF being our mid-segment. There are three individual mid-segments here. And I said in the video, or not I said, my bad, Master Geometrist Euclid, I believe. I always mess his name up. He said that it looks like a Triforce, little Legend of Zelda reference there. But this is going to come in handy for this next section here. So examples, we need to find CD, find the length of CD. If you notice here, this is a mid-segment triangle theorem. XC and CY, they're the same. YD and DZ are the same as well. So, and this is showing us that, hey, line CD is going to be equal to 1/2 of XC. So let me see that. Let me write that out real quick. So we're saying here, CD is equal to 1/2 of XZ. Okay, again, CD, which is the mid segment of this triangle, is equal to 1/2 of XZ. Remember, to find which one is the mid segment, it's going to be parallel to the triangle's base. Again, it's going to be parallel to the triangle's base. That being said, here, I know some of this stuff, so I'm trying to look for CD. That is my goal. And I know that XZ is 16. So then just to find CD, I do 1/2 times 16, and well, that's the same thing as 16 divided by 2, which we know is 8. I don't have units in this case, so I'll leave it like that. So that's all we're doing here. We're just trying to find the length of the mid segment, or maybe just find the length of X. And we saw that the mid segment is half of the triangle's base. Same thing for AC. AC here. Try yourself. Pause the video. Pause the video. See if you can figure out what is AC. Thank you for pausing the video. Let's come back here. So we saw that ST is the mid segment of this triangle. Therefore, ST is equal to 1/2 of AC. And do we know some information here? Oh, we know the value of ST. We know that ST is 4. Therefore, to find the value of AC, we can either do two things. One, just think about it in your head. A number times 1/2 equals 4. Clearly it's 8, right? If you want to do it in a more mathematical sense, I can isolate AC. So on both sides of this equation, I can multiply all this by 2. Multiply all this by 2 just to bring me that AC is going to be equal to 8. The mid segment is 1/2 of the triangle's base. So let's see some more examples. So same thing here. Pause the video. Try these two by yourself. And once you feel confident, push play on the video again. So go ahead and pause it. And now that we're back, so here we have different stuff here, but it looks the same, honestly. So in this case, KJ is our mid segment, and AC would be your base. Fill in what you know next. I don't know KJ, but I do know that AC is 18. So to find the value of length KJ, I'm going to do 1/2 times 18, which is just 9. Oh, my bad. Perfect. So it's just KJ equals 9. Same thing for this next one. Don't get confused here. They're trying to trick you. They gave you an extra side length. They said that, hey, TU is 32. Cool. I actually don't need to know that. So it looks like they just gave me an extra piece altogether. Find out which one is your mid segment and which one is your base. Remember, the mid segment and the base are parallel to each other. And so let me get my laser pointer out. That means my two lines that are parallel to each other will be my mid segment and my base respectively. So this case, we'll say, yeah, PQ and US. Those are our mid segment and base respectively. So that says here, PQ is 1/2 times my base. Again, PQ, which is the mid segment, is 1/2 times my triangle's base, which is US. So I don't know what PQ is because that's what I'm trying to find, but I do know that US is 30. So 1/2 times 30 is the same thing as 30 divided by 2, which is just 15. So we're about to show some different examples, nothing too crazy, but that's all this is saying here. The mid segment is 1/2 the triangle's base, and the mid segment and the triangle's base are parallel to each other. Now, this next example, find LN. But we have here some x's, we didn't have numbers. Same thing. We're still going to set it up the same way. Now, again, we said that EF is going to be 1/2 of the triangle's base. Let's fill in what we know. We don't really know the exact value of EF, but we do know that it's x plus 2. And again here, we don't really know the value of LN, but we know it's x plus 10. And look what we have here. We have an equation with x's on either side of our equation, but it's just one variable, so we're good. Now, there's two different ways to do this. It all depends on how you were taught in Algebra 1. You were either taught to go ahead and distribute the 1/2, or you were taught to go ahead and multiply the right side by 2. So here's what I'm going to do. I'm going to show you both options, and I'm going to let you choose what option you want to do one. Okay, so this is option 1 here, and I'll do option 2 over here. So let's just work out with option 1. Let's say option 1, your teacher, she taught you or he taught you to distribute the 1/2 to everything inside the parentheses. So 1/2 times x is just, 1/2 x. And 1/2 times 10, well, that's just 5. And now here to solve for x, what I'm going to do is I'm going to get x's on one side and everything else on the other. We tend to like x or a variable on the left side. We just tend to like that altogether. So subtract 1/2 x. So we have 1x minus 1/2 x. That would be 1/2 x. You're correct. And here, these just cancel. Cool. So then now going back to here, 1/2 x plus 2 equals 5. Well, to solve for x, I want to get everything else that's not x on the right side of my equation. So let's move this 2 to the other side. And then we got 5 minus 2. Wait, my bad. Let me go ahead and cancel this out. So 5 minus 2, which I'm confident on that. Now we have 1/2 x equals 3. Now, yes, to get x by itself, you can divide by 1/2. That works. But then you have 3 divided by 1/2. You may have remembered, or you may have been taught, that when you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. So you may have learned that keep, change, flip thing. We can do that if we want to, but what I'm going to go ahead and do here is I'm going to go ahead and let me pick a different color. I'm going to multiply by 2 on both sides. So that's an easy way to get rid of fractions, by the way. If you ever want to get rid of fractions, just multiply by the denominator. Again, if you want to get rid of fractions, multiply by the denominator. So here, when I do this, 2 times 1/2 x would be just x, and 3 times 2 is just 6, which makes sense, right? 1/2 times 6 equals 3. So that was, oh, yikes, that looks bad. That was one way, right? We said that x equals 6, and that was one way. Let me show you the other way. Again, it all depends on who your teacher was and what they taught you. Either way is correct. The setup for both ways are the same. X plus 2, x plus 10. Okay, it doesn't really matter which way you do, so we'll show you the second way. Maybe your teacher's like, you know what? If you get a fraction, always get rid of the fraction first. And what I just said, to get rid of a fraction, you must multiply by the denominator. So to get rid of this fraction, in this case, I'm going to multiply all of the, this won't look pretty, all of the right side by 2 and all of the left side by 2. So here's what happens on my, let me go back to black. Here's what happens on the right side. The 2 and the 1/2 will end up canceling and we get just x plus 10. And here on the left side, we get 2 times x plus 2. So we'll need to distribute that 2. So it'll be 2x plus 4. And now this looks a little bit simpler, right? I mean, just comparing these two steps right here, we have a x plus 2 equals 1/2 x plus 5, as opposed to the other side where we have a 2x plus 4 equals x plus 10. And if you notice here, the x, 2x, 2 and 4, 1/2 x, 1, 5, and 10, everything's just multiplied by 2. So that's good because we're still going to get our same answer. So same step, we want to get x by itself. It doesn't matter. Doesn't matter what we do first. Let's get x's on the same side. We tend to like the x variable on the left. That's just something we tend to like growing up. So that means here, oh, my bad, that would cancel out. And then we'll get x plus 4 equals 10. And hey, to solve for x, this isn't too bad. We need to move that 4 from the left side to the right. So that means let's subtract 4. If you notice, we get the same answer either way. Biggest thing here is getting these set up correctly. There's some leniency on what to do here. There's some leniency. And there's, again, multiple methods you can do. But you can't get the setup wrong. The mid-segment is 1/2 of the triangle's base. Again, the mid-segment is 1/2 of the triangle's base. Another example here, very same. So set up RQ is 1/2, and we'll say SU. The mid-segment, which is RQ in this case, is 1/2 of the triangle's base, which is SU in this case. Now, with this here, plug in what you know. We know that RQ is x minus 2, and we know that SU is going to be x plus 3, but again, it's all of SU, so do not forget those parentheses there. If you forget the parentheses, you'll end up probably making a mistake. Now, in this scenario, I recommend going ahead and doing option 2 of what we did like last time. The reason why, if you do option 1, totally fine. People tend to freak out with fractions. And so when I distribute that 1/2 to everything in the parentheses, I would end up having 1/2 x plus 3 halves. And then you have to do some work there. Okay, I'm going to do option 2 here. If you decide to do option 1, that's totally fine. That's on you. You do you. But I'm going to show option 2 here. So here, my goal, let's get rid of the fractions. We don't like fractions, so let's get rid of them. So since that's 1/2, I'm going to multiply by its denominator. So that means on this side here, let's multiply everything by 2. But if I do what I did to one side, I must do to the other as well. So that means here, distribute that 2. So 2x minus 4. That 2 and the 1/2, they cancel, or they equal 1. That means on the right side, all I have is x plus 3. Now that's a little bit better to see and manage, because now to get x by itself, to get x by itself, well, let's just move all the x's together. So we end up getting 2x minus x, which is just x, and just a 3 on this side because, perfect, these x's cancel. And then finally, the last step here, just to get x by itself, let's move that -4 to the other side. Perfect, amazing. I just realized we did not finish this question. My bad. What does the question say? Find RQ. We just found the value of x, though. We didn't find RQ. And so RQ, remember, RQ is x minus 2. But we didn't know what x was. That's why we did all this algebra. But now we know what the value of x is. We know the value of x is 7. Therefore, RQ is actually a length of 5. That means on our last example, let's go ahead and fix it. So good job. We found x using 2 different methods, but we didn't actually find ln. So ln here is x plus 10. And so we have, instead of x, we have a 6. Perfect. So let me go back here. So that means we have one more example. I believe we have one more. Awesome. So here, to find a ij, we need to find x, then plug it in when you get ahead of the game. So again, this is like one of those where they give you some extra information you don't need to know. We need to find ij. So first determine which one is your midsegment and which one is your base. So go ahead and pause this video. I'm watching you. Pause the video. Try this by yourself, and then play the video once you got an answer. It's okay to be wrong. It's okay to be wrong, but it's not okay to not try. Cool. Thanks for pausing the video. To find ij here in this situation, this is the unnecessary piece. I don't care about TU or UT. I care about UT, Texas Longhorns, but I don't care about UT in this case. IJ is my midsegment, and VT is my base. Remember, the two sides that are parallel to each other are the midsegment and its base, respectively. So let me get my pen out. So that means here, IJ is equal to 1/2 of VT. So with this here, plug in what you know. We know, well, we kind of know. We know IJ as x minus 3. If we know that VT is x plus 6. And for the sole purpose of making sure I diversify this a little bit, I'm going to go back and do that option 1 we did 2 slides ago. If you want, go ahead and do option 2. Option 2 may seem easier to you. Please do that if you think it is easier. I'm going to do option 1 just so you have more practice with it. All right? So here, the option 1 was like, hey, go ahead and distribute that 1/2. Just go ahead and distribute it. We can take on fractions. We're not that scared of them. They're not that mean. Not that mean. So x minus 3 equals 1/2 x, and then 1/2 times 6 is the same thing as 6 divided by 2. And so here, okay, cool. We just need to get, perfect. We didn't get the x's on one side of my equation. So we like to have x's on the left side. It doesn't matter, but we just tend to like that. So here, 1x minus 1/2 would be just 1/2 x. And here now, to solve for x, we need to go ahead and move everything that's not x on the other side. So let's move that -3 over to the right side, or I guess right side. Look at the camera. So now we got 1 half x equals 6. And here, again, remember, to get rid of a fraction, you multiply by its denominator. To get rid of a fraction, you multiply by its denominator. So that means I'm going to multiply both sides by 2. But again, are we done? We are not, Mr. Garcia, because you will fix your error unlike last time. Ij is x minus 3, but now we know that x is actually, in fact, 12. And, well, we know that 12 minus 3 is 9, which shows us that ij is a length of 9. And if you want to check yourself as well, you can verify. Hey, plug in 12 to TV or VT. 12 plus 6 is 18, and 9 is 1 half of 18. Ij is 9. This is the triangle mid-segment theorem. Again, I'll keep repeating that. Keep repeating that where we're at. Cool. A mid-segment is parallel to its base and 1 half its length. Again, mid-segment is 1 half times triangle's base. I hope you enjoyed the video. If you enjoyed it, please make sure to complete your assignments. That shows me how much you enjoyed it. You will have homework over this. Check Canvas for more information. It'll be on Delta Math. I hope that you have a great rest of your day. That was a bad bow, man.